All right, so this section is going to be on water. And so what I need you to know is water is fairly unique, which, we just went to Mars. We've got a vehicle on there looking for life. And what I was amazed at, if you always look at what we're really looking for, we're looking for evidence of water. Our assumption is that life can't exist without water. Water is a unique product, substance, because it's actually found in all three states under normal temperatures and pressures. And so what we're looking at is it's found in a liquid, solid, and a gas. And so what we want to do is talk about water's properties, and there are 7 of them. So what I need for you to keep in mind is that for each of these properties, you want to know the definition. You want to know why that's important to life, and then kind of the bigger picture, what I call the bigger picture, and why water has this property. So we'll go through that with all 7. Actually, 3 of them will group together, but the rest of them will be individual. So let's move on and look at a water molecule. Water is made up of an oxygen molecule and 2 hydrogens. And so I want you, when you're looking at this structure, I want you to remember that water is a polar molecule and polar covalent. And so here, this oxygen is highly electronegative, which means it attracts electrons. And so then you have a partially negative charge on the big orange oxygen here. And then the white ones, the hydrogens, have a partially positive charge. And those are attracted to each other. And so that creates the hydrogen bond. Okay, so within a single water molecule, you have polar covalent bonds. And between 2 water molecules, you have hydrogen bonds. So very important, need to remember that. Okay, so what we want to do is look at the 7 properties of water. And I'm going to, again, here's 3 of them. And I want you to know the definition. So adhesion is water actually sticks to other things, to other molecules. Cohesion is water sticks to other water molecules. And then surface tension is the amount of energy it takes to break the surface of the water. And so all 3 of those, you need to know those definitions. I've lumped them together today for, okay, first of all, then why does water have these properties? Adhesion, cohesion, surface tension. And the answer always is hydrogen bonds. So you go back, it's these hydrogen bonds. Water has more hydrogen bonds than any other substance because they're all packed in. And so water has all of its properties. It's why it's so unique, is because of all those hydrogen bonds, just the amount of hydrogen bonds. Okay, so let's talk about why these 3 are important. They're important because it's what it takes for water to actually go all the way up one of these, like a eucalyptus tree, which could be up to 100 feet tall. This is actually a stem. It's a tibia plant. I don't really care, you know that. But here you're looking at 2 years of xylem. And then this darker structure out here is phloem. That's where food is. This is where the water is. And water has to move up. And it actually uses these 3 different processes to get water up this tree. Now, we're not going to go over this biotube. We actually spent probably 5 to 10 minutes on it. So it's a little complicated. We're not going to go over that, but it is important. So all 3 of these are necessary to create the suction for transpiration. All right, surface tension. Here's another example. This is a little water strider, an insect. Now I can sit on top of the water and actually walk because it does not weigh enough to actually break the surface of the water. To do that, you have to break water molecules, the hydrogen bonds between the water molecules. And so what you can see is it's sitting there. Notice it's not on the edges of its legs, but what it's actually doing is spreading that out over the surface to allow for this behavior. What is the largest animal that can walk on water? Usually in class I get Jesus. Okay, well it's close. It is actually what they call a Jesus lizard. Its real name is called the basilisk lizard. And you can see it here, and its toes are very, very long, and they've got little ridges on them, and it allows them to run. This thing would be the size of a small green iguana, probably a little bit lighter in weight. You can see these out. I was in Costa Rica and actually got to see one of these on a log out in the river, and as we got closer, it took up and ran. And so anyway, so pretty cool. You cannot do this. Just letting you know. And I love it. So here is Brooks, a shoe company that is taking advantage of this. So this is advertising great, except for this is not a basilisk lizard. This is actually a green iguana. So get your animals straight. Take a biology class. All right. So the fourth property is water has a high specific heat, higher specific heat than other things. So again, the question is why? And the answer is hydrogen bonds. That's always the answer. If you don't know the answer to a water question, write hydrogen bonds. Chances are you're going to get them right. What that means is that it takes a lot of energy to raise the temperature of water. So specific heat is, by definition, is the amount of energy it takes to take 1 gram of the substance and raise it 1 degree Celsius. And so water has a high specific heat. It takes a lot of energy just to raise it that 1 gram. Heat is actually a measurement of the molecules moving. And to get those molecules moving, you have to break the hydrogen bonds. And so here we have a lake, and to get this lake to raise this temperature, what it takes is a lot of energy to get those molecules moving, high specific heat. And this is why most people like to live by the beach or by a lake. So what I want you to know, big picture, is that high specific heat, this property allows for local areas to be cooler, to stay more uniform in temperature. So for instance, if you look, here's a day in August in LA, where do you want to live? You want to live at the beach or live in the desert? And what you'll notice here is the temperatures are in the 70s because of this big thing we call the ocean. When the sun beats down on Southern California, it beats down the same kind of everywhere. But what's happening is here, this is a big heat sink. So some of the energy from the sun is being used to heat up the ocean. Now the ocean's not heating up very quickly because it's so huge, but that temperature then is not in the air. Now notice if you go out to Palm Springs where there isn't any water, there is nothing to take out that heat. And so those temperatures get up into the upper hundreds. All right, the other thing I want you to understand is during the wintertime, it's actually the opposite. So what happens is, or even at night, once the sun goes down, heat gets re-released from the Pacific Ocean and actually warms the temperature. And then in Palm Springs, the surface, the sand and things, the asphalt, sidewalks out there are releasing heat, but it's not quite the same. So what you need to realize is if you live at the beach or you live next to a big lake, the daily temperature range is a lot smaller than if you go out to Palm Springs, where it can get all the way up into the upper 120s and actually drop all the way down into where it snows. So kind of get this huge range. You can get high specific heat, moderates local climate. Another one is high heat of vaporization. Heat of vaporization is the amount of energy it takes to turn 1 gram of a substance from a liquid to a gas. Water has a high heat of vaporization. Again, you have to break, the reason is you got to break those hydrogen bonds. We use this to cool ourselves. When we get hot, we sweat. And when we sweat, it puts moisture on our skin. and that pulls heat off our body to evaporate it. And so that is why if you're out in the heat, it is a good idea to maybe have some water. You can spritz yourself. They have misters at a lot of the amusement parks. The idea behind this is to keep you cooler. Things like dogs, that's why they pant. They need a large surface of water. They don't have a sweat gland, so they use their tongue. All right, another property number 6, I believe, is water expands when freezing. This is pretty unusual. What happens is most substances, the colder they get, the more dense they are, the thicker they are, the heavier they are. Water, on the other hand, actually expands, so it is lighter. That is why ice floats. Now, why is that? And the answer is hydrogen bonds. Okay, so here's the question then. Why does it matter to me, big picture, if my ice is on the top of my glass or the bottom of my glass? The answer is doesn't. But it does matter for things like this. So just to get the idea, okay, so as water cools off, you've got water molecules and they're moving, and as they cool off, they get slower and slower, and they start packing closer and closer together. Water is actually densest at 4 degrees Celsius, but we know it freezes at 0. What happens when it gets below 4 degrees Celsius? Really trying to pack in, but that's when those hydrogen bonds form. And the hydrogen bonds have a size, and that will push the molecules farther apart. So here we would see gaseous water molecules. Here we would see water molecules that are being chilled down to 4 degrees Celsius. And then here you see it when it's freezing, where you actually have those hydrogen bonds pushing those molecules apart. All right, and the last property is water is considered to be the universal solvent. It dissolves most things. So real quickly, a solvent is something that dissolves something else. So we have solutions. A solution is a mixture of solute and solvent. For example, salt water. Salt would be the solute, water would be the solvent, and then the salt water would be the solution. If you know oil paints, oil paint would be a solute. The solvent, water won't break up lipids. So you will use something like paint thinner, which is a solvent, which would dissolve it. So just to give you an idea of what those are. So we'll go back and look at this. So what we need to know for the universal solvent, again, is hydrogen bonds. Here NaCl, ionic bonding. Water will allow NaCl to dissociate and come apart. Over here we have some krill. The important part about this, and the reason we're showing you this, is they're using oxygen out of the water. And for that to happen, it actually has to diffuse across the gills. You would not actually be able to breathe without moisture in your respiratory tract. So water actually kind of gets inside, lands in the alveoli where there is moisture, and then it dissolves across. That's how we get things through your bloodstream. So again, water is a universal solvent. We already did this slide. And so those are the 7 properties. So again, know the 7 properties, know their definitions, and then also know why water acts that way, and then also the big picture for all of those. So we will stop the recording.